Good afternoon, guys. My name is Darrell. We're here today. We're going to discuss the theory of the air conditioning cycle. You can see on the board, I have it already drawn out for us to save us a little bit of time. But before we get started, I got to ask, how many like to travel? Seems like everybody's traveling. One thing that I did in my younger days, I got to travel a lot. And going across the United States, I got to see that we have continental divides. And I like to call them the Great Divide. And after my experience of traveling, I started applying, thinking about how in the world can the Great Divide, the Continental Divide, apply into my life. And I started looking at it not only in my life, seeing a dividing point when I changed, but also started applying it to theories of my industry, such as how the heat engine works. Four-stroke engine has a continental divide, has a Great Divide. The climate control system, the air conditioning circuit has a Great Divide. And if you look at it, you see what I call the circle of life for air conditioning. We have a starting point. The starting point is the compressor. And you guys, when you start dealing with this, you've got to know all your components and you've got to know the fundamentals of them. But we have to start with a compressor. Without a compressor, it's not going to move and pressurize anything. So we have a compressor. It is mounted on the engine. It is belt driven on all medium and heavy duty trucks that you're going to be dealing with. And it takes the refrigerant and it pressurizes it and it sends it to the condenser. That'll be the second component. The second component, the condenser, its job is just simply remove heat. And we're going to cover that in just a moment. We're going to touch on all the components first real fast. It leaves the condenser and goes to the TXV. From the TXV, it goes to the evaporator and back toward the compressor. Now let's spend a little time with our components. As I said earlier, the compressor is engine mounted. It's belt driven. There's different types of compressors. You have a piston type compressor. You have a radial type compressor and a axial type compressor. The ones that you're going to be dealing with mostly in medium heavy duty trucks will be the little piston type compressors. All right? The compressor takes the refrigerant and it takes it and it pressurizes it, intensifies it, speeds it up, and it increases the pressure on it and sends it down the line to the condenser. Now the condenser is made up of very small tubes. All right, so when this high pressure gas, this refrigerant, at this time is turned into a high pressure gas, as it leaves the compressor, it comes to the condenser, which is made up of little tubes and cooling fins. As air flows across this condenser, it takes the heat that has been captured earlier on in the cycle. It takes this heat and it removes it and displaces it out into the ambient air. Okay, it takes it and turns it from a high pressure gas by air flowing across it and turns it into a high pressure liquid at the end of the condensing cycle. From there, it continues on as a high pressure liquid to right here is where we get the Great Divide. If you look at my drawing, I have a green dotted line separating the east from the west to a thermostatic expansion valve or an orifice tube. Now, the thermostatic expansion valve or orifice tube, its job is twofold. It creates pressure, restriction, and it allows it to turn from high pressure liquid to low pressure liquid. Now, once it leaves the thermostatic expansion valve or the orifice tube as a low pressure liquid, it travels over here to the evaporator. Now, the job of the evaporator and its location is always going to be located inside the passenger compartment. Its job is to capture heat. Now, as the low pressure liquid enters into the evaporator, it enters in the bottom of the evaporator and it starts to flood the evaporator. All right, we have air going across the evaporator and it takes that low pressure liquid and starts to boil off in changing the state of matter from a liquid back into a gas. Okay, so it's capturing that heat that the blower motor inside the cab is forcing across the evaporator tubes, and it's capturing that heat, and it takes it and turns it into a low pressure gas. So as the evaporator starts to flood, the boiling point on the refrigerant is very low, and it starts to boil it off, and it changes state of matter, and it goes back to the compressor as a low pressure gas, where in turn it goes back into a high pressure gas by intensifying it and pressurizing it. Now, there's one thing that I've learned with heat. You can't remove heat. You can displace heat. I can take it and put it from one point to another point, but to take heat out and totally remove it from existence is not going to happen. You can slow down the movement of heat. You can transfer it from point A to point B, is which the air conditioning cycle does, but you can never totally do away with heat. Heat is like a schoolyard bully. And you guys in grade school, I'm sure many of you were confronted with schoolyard bullies just as I was. That's what heat is. Heat always wants to beat up on what is cold. Okay, it can't stand it if something next to it is cold, because it's going to run right over there and attack it and warm it up. So this is just a small example of the air conditioning cycle. But now I have the great divide separating the east from the west, but if you look here, I have another divide that separates the north from the south. If you'll notice, if you look on the east side, I have circled in red high pressure gas and high pressure liquid. The red signifies that this side right here is always going to be hot. If you look over here, this side is going to be encircled in blue, which signifies that side of the cycle is always cold. All right, cold, when you have this side over here, the cold side is normally going to be, if you're looking on your gauges, anywhere from 35 to 40 psi. When we deal with heat on this side, heat comes from what? Heat comes from restriction. Okay, anytime you have restriction or resistance in a circuit, it generates heat. Just like on the electrical circuits or the hydraulic circuits, anytime there's resistance, you start generating heat. Same thing about the air conditioning. Right here is our restriction, so we have heat with pressure. We're going to be on our pressure gauges anywhere from 200 to 275 psi. So anytime you're dealing with these two cycles, you need to know which side you're dealing with, either the hot side or cold side, when you're looking at your gauges. Now, I know all that is a mouthful and it's a lot to take in, but right now I want to stop and ask, do you have any questions on just what little bit we've covered?
How does the refrigerant work exactly?
Okay, that's a good question. How the refrigerant works, refrigerant is the medium that captures the heat and expels the heat. Okay, so as I said, as it goes from the low pressure side, we pull a vacuum on the air conditioning system, which lowers the boiling point. So the refrigerant is going to boil off like at negative 16 degrees versus water boils off at 212 degrees at sea level. So that refrigerant boils off, it captures that heat when it changes the state of matter, and then we expel it on the condensing side. Good question. Anybody else?
What makes the refrigerant boil?
What makes the refrigerant boil? It being under pressure or having a vacuum point on it, lowering the pressure, I should say. The heat, as it goes through the evaporator, from the time it goes in on the bottom port, it starts to flood till it comes out. We call that the superheat mode. You're going to gain about 10 degrees variance the time it comes in. So if it comes in at 30 degrees, it should go out at about 40. Or if it comes in at 34, it should go out at 44. It should have about a 10 to 12 degree variance there. The heat flowing across the evaporator as the refrigerant is going through the tubes, the heat in the air is blowing across it, causes it to boil off and change state of matter. Good question. Anybody else? Good understanding?
Yes, sir.
Is it Fahrenheit or Celsius?
You can read it in either way. You can read it in Fahrenheit or Celsius. I always read in Fahrenheit. That's just what I'm accustomed to. My gauges read in both, but everything that I will ask you to perform will be given examples in Fahrenheit. No one else? So when we go into our looking at our cycle over into the lab, I want you to keep in mind, even though it's not in a circle, so to speak, the compressor is going to be located here, and the condenser is going to be out in front of the vehicle, and the evaporator is going to be back in the cab. Just remember that it is a circle. The cycle is a circle. So if you can visualize that in your mind, and you know how each side works, then you shouldn't have any problem in learning how to diagnose the climate control system. One more thing that I failed to mention. What's the difference between the right side and left side?
Right side's high pressure, left side's low pressure.
Okay, high pressure and low pressure, hot and cold. What about the north from the south? Is there any differences there?
One's liquid, one's a gas.
One's liquid, one's gas. If you look on the bottom side, you always have a liquid. In theory, gas will always be on top. So I hope this helps you come to a little bit better understanding of the climate control system and how the air conditioning system works. Thank you very much.